Quadratic factorize algebraic expression. Introduction of quadratic equation. Representation of word problem in quadratic equation form. Finding roots of quadratic equation. Finding roots through completing squares. Quadratic formulas. Quadratic equation. Dear students, we have learnt expressions and equations. Equation is a polynomial whose value is 0 for a specific value of variable used in it. Any polynomial written in variable x is called the polynomial in x, and it is denoted by p into bracket x. The highest power of variable within the term of polynomial is known as degree of that polynomial. The polynomial p of x of degree 2 is called as quadratic equation. 2x plus 5x square minus 4 is an example of quadratic equation. If we write the terms of polynomial p of x in descending order of their powers, then it is the standard form of that polynomial, or say equation. Therefore, 5x square plus 2x minus 4 is equal to 0. Call the standard form of a quadratic equation 2x plus 5x square minus 4. 2x square plus x minus 300 is equal to 0. 2x square minus 3x plus 1 is equal to 0. 4x minus 3x square plus 2 is equal to 0, and 1 minus x square plus 300 is equal to 0 are some examples of quadratic equations. Representation of word problem in quadratic equation form. Now let us try to transform some word problems to quadratic equation form. Ramesh and Jen together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. Now, how many marbles they had to start with? Here, in the example, we have given total number of marbles both had are 45. Suppose Ramesh had x number of marbles, then the number of marbles Jen had is equal to 45 minus x. Now, both have lost 5 marbles. Therefore, the number of marbles left with Ramesh are x minus 5. The number of marbles left with Jen are also 45 minus x minus 5 is equal to 40 minus x. We have given product of left marbles they now have is 124. Therefore, into bracket x minus 5 into another bracket 40 minus x is equal to 124. Multiply x with second bracket and then multiply minus 5 with same bracket, we get 40x minus x square minus 200 plus 5x is equal to 124. Write it as minus x square plus 45x minus 200 minus 124 is equal to 0. The sum of minus 200 and minus 124 is minus 324. And if we change the signs, we get x square minus 45x plus 324 is equal to 0. This is the required mathematical representation of the given word problem in quadratic form. Finding roots of quadratic equation. Let us use the knowledge of splitting middle term for finding the roots of a quadratic equation. Let us see how. Here in this equation, we split minus 9y in such a way that sum of split terms should be equal to the middle term of quadratic equation, and product of split terms should be equal to the product of first term and constant term of equation. Find the roots of the equation 2x square minus 5x plus 3 is equal to 0 by factorization. Let us first split the middle term, that is minus 5x. Minus 2x minus 3x. So, 2x square minus 5x plus 3 is equal to 2x square minus 2x minus 3x plus 3. Now take 2x common from first two terms and take 3 common from next two terms. So we get 2x into bracket x minus 1 minus 3 into bracket x minus 1. Again take common x minus 1. So we get x minus 1 into another bracket 2x minus 3. Now 2x square minus 5x plus 3 is equal to 0 can be rewrite as 2x minus 3 into another bracket x minus 1 is equal to 0. If 2x minus 3 is equal to 0, then x is equal to 3 by 2. And if x minus 1 is equal to 0, then x is equal to 1. X is equal to 3 by 2 and x is equal to 1 are called the solutions of the equation. In other words, 1 and 3 by 2 are the roots of the equation 2x square minus 5x plus 3 is equal to 0. To verify that these are the roots of the given equation, put both values one by one in the equation and we get 0, the right hand side of equation. Finding roots through completing squares. Consider the quadratic equation x plus 2 whole square minus 9 is equal to 0. By taking square roots of both sides, we can easily get x is equal to 1 or x is equal to minus 5. In this way, we can easily get the roots of equation x plus 2 whole square minus 9 is equal to 0 because the term containing x is completely inside the square. But what if the equation is x square plus 4x minus 5 is equal to 0? Probably we may apply factorization unless and until we think that x square plus 4x minus 5 is nothing but x plus 2 whole square minus 9. We can change any quadratic equation in the form of x plus p whole square minus q square is equal to 0 and then we easily find its roots. Let us see some examples of it. Let us find the roots of x square plus 4x minus 5 is equal to 0. Through completing squares, we can write x square plus 4x as x square plus 2x plus 2x. Take x common from first two terms, we get x into bracket x plus 2 plus 2x. Now add and subtract 4. We get x into bracket x plus 2 plus 2x plus 4 minus 4. Now from 2x plus 4, take 2 common. In this way, we get x into bracket x plus 2 plus 2 into bracket x plus 2 minus 4. If we observe first two terms, again we can take x plus 2 common. Therefore, we get x plus 2 into another bracket x plus 2 minus 4. Now, x plus 2 into another bracket x plus 2 means square of x plus 2 and place remaining minus 5 here. We get x plus 2 whole square minus 9 is equal to 0. Now we have x plus 2 whole square minus 9 is equal to 0. It means x plus 2 whole square is equal to 9. Therefore, we can easily get roots of equation x plus 2 whole square minus 9 is equal to 0. That is, roots of equation x square plus 4x minus 5 is equal to 0. Quadratic formula. For the quadratic equation ax square plus bx plus c is equal to 0 and a is not equal to 0. If the value of b square minus 4ac is greater than or equal to 0, then the roots of the quadratic equation ax square plus bx plus c is equal to 0 are given by minus b plus in the root b square minus 4ac whole upon 2a and minus b minus in the root b square minus 4ac whole upon 2a. A quadratic equation ax square plus bx plus c is equal to 0 has 1. Two distinct real roots if b square minus 4ac is greater than 0. 2. Two equal real roots if b square minus 4ac is equal to 0. Third, no real roots if b square minus 4ac is lesser than 0. Find the nature of roots of quadratic equation 2x square minus 4x plus 3. We have given a quadratic equation 2x square minus 4x plus 3. Compare the equation with ax square plus bx plus c. We get a is equal to 2, b is equal to minus 4, c is equal to 3. Now put the values of a, b, c in b square minus 4ac to get the nature of roots. Therefore, minus 4 square minus 4 into 2 into 3. We get 16 minus 24, that is minus 8. The value of b square minus 4ac is minus 8, which is less than 0. Therefore, nature of roots of quadratic equation 2x square minus 4x plus 3 is not real. Hence, the roots are minus 4 plus root of minus 8 upon 4 and minus 4 minus root of minus 8 upon 4 are also not real. Summary. In this chapter, you have studied the following points. 1. A quadratic equation in the variable x is of the form ax square plus bx plus c is equal to 0, where a, b and c are real numbers and a is not equal to 0. Second, a real number alpha is said to be a root of the quadratic equation ax square plus bx plus c is equal to 0. If a alpha square plus b alpha plus c is equal to 0, the zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c is equal to 0 are the same. 3. If we can factorize ax square plus bx plus c, a is not equal to 0, into a product of two linear factors, then the roots of the quadratic equation ax square plus bx plus c is equal to 0 can be found by equating each factor to 0. 4. A quadratic equation can also be solved by the method of completing the square. 5. Quadratic formula. The roots of a quadratic equation ax square plus bx plus c is equal to 0 are given by minus b plus minus under root of b square minus 4ac divided by 2a, provided b square minus 4ac is greater than or equal to 0. 6. A quadratic equation ax square plus bx plus c is equal to 0 has 1. Two distinct real roots if b square minus 4ac is greater than 0. 2. Two equal roots, that is, coincident roots if b square minus 4ac is equal to 0. And third one, no real roots if b square minus 4ac is lesser than 0. So that is all in this subtopic. Keep learning.